Basic metallurgy. Metallurgy is the branch of science and material engineering that focuses on the study, production, and processing of metals. It encompasses steel manufacturing, forging technology foundry, technology including casting processes, powder metallurgy material, selection, corrosion, prevention, and control welding technology composites, e.g. ceramics, resins, and matrix materials, heat treatment processes. These areas aim to improve the performance, durability, and usability of metal components. Heat treatment phase diagram, heat treatment diagrams of steel, such as the time-temperature transformation, TTT, and continuous cooling transformation, CCT diagrams, are essential tools in understanding how heat treatment processes affect steel's microstructure and properties. These diagrams illustrate the phase transformations that occur at different temperatures and cooling rates, enabling precise control of hardness, toughness, and other mechanical properties. More about iron-carbon phase diagram austenite, a solid solution of carbon in a non-magnetic form of iron, stable at high temperatures. It is a factor of some forms of steel. Cementite, a hard, brittle iron carbide, Fe3C, present in cast iron and most steels. Ferrite, a ceramic compound consisting of a mixed oxide of iron and one or more other metals. It is used in high-frequency electrical perlite, a form of obsidian consisting of glassy globules, used as insulation or in plant growth media. Brenite, a combination of ferrite and cementite in ferrous metals that is harder than perlite. Martensite, a hard and very brittle solid solution of carbon and iron that is the main constituent of hardened steel. Some example of the structure of hypereutectoid steel. Slow cooling. Common in annealing. It allows the formation of coarse perlite, resulting in softer, more ductile steel suitable for machining. Medium cooling. Used in normalizing, it produces finer perlite or bainite, improving strength and toughness compared to annealing. Fast cooling. Achieved through quenching in water, oil, or brine, it rapidly hardens steel by forming martensite, increasing hardness but potentially causing brittleness. Some example of the hardness measurement tester: Rockwell, hardness tester, Brunel, hardness tester, Vickers, hardness tester, Micro Vickers, hardness tester. Case depth measurement in heat treatment determines the hardened surface layer's depth to ensure required hardness and performance for wear, resistance, and strength. It uses methods like destructive micro-hardness testing and non-destructive techniques such as eddy current testing. Traverse from surface to core in heat treatment describes the material's thermal or structural changes from its hardened surface to its softer ductile core. This balance is vital for applications needing a durable surface and a tough core, like case-hardened steel components. Some examples of microstructures for reference. Hardness testing. Hardness testing evaluates a material's resistance to surface indentation or abrasion. Since no universal scale exists, each test uses its own scale. Common methods include Brunel, Rockwell, Vickers, Knoop, and scleroscope. Macro hardness tests use loads above 1,000 grams, e.g. Brunel and Rockwell tests. Micro hardness tests use loads between 1 and 1,000 grams, e.g. Vickers and Knoop tests. Rockwell test types standard. Rockwell, suitable for thick materials using loads of 60 kilograms or more. Superficial. Rockwell, designed for thinner materials with loads of 15, 30, or 45 kilograms. Keynotes use micro-hardness tests, Vickers or Knoop, for thin materials less than 0.4 millimeters. Calibrate hardness testers annually. Verify daily with test blocks. Prepare smooth, polished samples for accurate results. Proper preparation and technique ensure reliable hardness measurements for materials of all thicknesses. Failure analysis. Heat treatment. Failure analysis identifies and solves problems in heat-treated components. Failures often happen due to design flaws, improper processes, or material defects, leading to issues like cracking, deformation, or low hardness. Analyzing these failures helps improve processes, enhance material quality, and prevent future problems in tools, machinery, and aerospace parts. The classification scheme for metal alloys in heat treatment uses diagrams to group metals by composition and properties, such as steels or cast irons. These diagrams link heat treatment methods, e.g., annealing, quenching, to alloy types, showing how microstructures are optimized for strength, hardness, or ductility. Example: special characteristics of steel low carbon. Steel, also known as mild steel, contain 0.05% to 0.32% carbon. Tough, ductile, and malleable, easily joined and welded. Poor resistance to corrosion, often used a general-purpose material. Use: nails, screws, car bodies, structural steel used in the construction industry, etc. Medium carbon steel contains 0.35% to 0.5% of carbon. Offer more strength and hardness, but less ductile and malleable. Use: structural steel, rails, and garden tools, etc. High carbon steel, also known as tool steel, contains 0.55% to 1.5% carbon. Very hard, but offers higher strength, less ductile, and less malleable. Hand tools, chisels, punches, saw blades, etc. Cast iron contains 2 to 4% of carbon. Very hard and brittle. Strong under compression. Suitable for casting, can be poor at a relatively low temperature. Use: engine block, engineer vices, machine parts, etc. Stainless steel, steel alloyed with chromium, 18%, nickel, 8%, magnesium, 8%. Hard and tough. Corrosion resistance, comes in different grades. Use: sinks, cooking utensils, surgical instruments, etc. High-speed steel, medium carbon steel, alloyed with tungsten, chromium, vanadium, very hard, resistant to frictional heat even at high temperature. Use: machine cutting tools, lathe and milling, drills, etc. Thermocouples are crucial in heat treatment processes, used for temperature monitoring and control during treatments like annealing, quenching, and hardening. Some components can be treated. This will be covered on the channel. Industrial safety, basic safety instructions, furnace, basic maintenance. What is heat treatment? Heat treatment processes. Heat treatment, production, marketing, and quality management systems, basic metallurgy, heat, treating materials, classification scheme for various metal alloys, special characteristics of steel, uses of materials, aerospace plasma, nitriting, powder, metallurgy, special process brazing, and many more.